GM's in the chat. That's nice. Costa Rica. Hey, Lewis, GM, Kartike. We have quite a lot of people from Costa Rica hacking during this
Yeah,
hackathon, so that's nice to see. That's
nice.
quite cool. So let's give it a couple of more seconds until people are joining the session, and after that we can kickstart the session. I hope you're all ready. I'm always excited for a dojo session. It's always fun to watch, and it's always great to learn from the one and only Glihm.
Thank you, man. Very glad to be here. GM,
Cool.
guys.
So let's do the intros and we'll get started. So again, GM, everybody, welcome to our third workshop of the day. I hope you are already covered with Starknet fundamentals and rapid dApp development with Scaffold Stark. Now it's time to explore the on-chain games and dApps with Dojo. For the newcomers, this is the second day of the Reignite Hackathon. We have 33,000 in start prizes. Make sure to join our Telegram group for team formation, technical support, or real-time updates, and use the QA section for any questions during the workshop. Remember, we do have a bounty of 5,000 in start prizes for building with Dojo, which is sponsored by Cartridge. So this workshop is perfect if you're interested in building on this bounty. The recording we this session is recorded, so for those who are missing some parts out, we can share this recording after the call. And with that being said, I'm excited to introduce Glihm, core contributor to Dojo Engine and developer at Cartridge. He's the perfect person to guide you through building a game or a dApp with Dojo. And in this session, you'll learn how to write smart contracts and read data using Torii. Let's dive into the world of Dojo. Glihm, the stage is yours.
Thank you very much, Robert, and thank you very much, guys. Very happy to be here. I don't know why in my mind it was a 2-hour session, so I might be a go quicker on different things. But the idea is, yeah, so I'm Glihm working in Cartridge, as Robert mentioned, and the idea of today is giving you the mental idea of how Dojo works, what is the difference with a regular smart contract development, and then how you can go very quickly actually building an application and having your data from the blockchain directly into your client application. So this is what we will see today. Without further ado, I will just dive into it. I will share my screen, and I will just start with a few technical things in theory. But the idea is diving very quickly into the code. So can you see my screen and the drawing? I guess yes. I will just make it perhaps a bit
Yes.
bigger. And like this, we might be okay. So if we get back to the basics of how a smart contract works into Cairo is what you as a developer, you write Cairo code, right? This Cairo code is being compiled when you use build locally, for instance, and this is compiled into a Sierra file. Sierra file being an intermediate representation of your Cairo code that you have written. And then you send this Sierra file, and let's say this is Starknet. So this is a network. Currently, it's only one sequencer, but the idea is it's going to be decentralized. But the idea is you have this Sierra file containing your code. You send this to Starknet network, and this is what we call the declaration. Okay, declaration. When we declare, we just upload the code, and the code is on the blockchain, ready to be executed. And then when you want to actually work with your contract, you send another kind of transaction, which is an invoke. And what we will do in this transaction is we will actually deploy the contract. So the second step is deploying the contract. And when we deploy the contract, we take this code we have actually declared, and this is, I think you're familiar with it, but I will remember it. We have a class hash. A class hash is a way to identify a compiled program in a unique manner in Starknet. And the idea is once it's declared, we can reference this class hash to say, I want to deploy this contract using this class hash, which means this code. And this will actually initialize a new instance of the contract, right? So when we declare, we talk about code. And when we deploy, we talk about an instance. And an instance, what we actually do is we ask to have a new storage completely empty for this contract. So as you know, guys, in blockchain, when you want to change the state of the blockchain, in the case of Starknet and others, but that would be more specific to Starknet, you actually want to change what's inside the storage slot of this blockchain. You want to declare a new contract. All of this is changing the Starknet state. So when we deploy, we actually have a fresh contract with a brand new storage. How the storage works, and I will just give a brief idea of that into Starknet. Let's say you have the contract address, which is, let's say, 0xA. And in this contract address, we have a new storage completely initialized. And you have to see the storage as, let's say, your bookshelves, right? So you have a shelf, and in each one of them, you can put one felt, right? So you have one felt here, and they are identified by indexes. So you start to 0x0, 0x1, and you go up until the felt max value, okay? So the idea is the storage is a huge shelf that you can use to actually store data. And what happens if your data are actually longer than one felt? Because as we can see here, in one shelf, we actually have one felt. So the idea is, depending on the storage algorithm that is used in the case of Dojo or the built-in Starknet plugin, the idea is you might use different and several shelves to actually store one data that you will serialize. And then your data will actually be distributed in these different slots. Okay, but this is the core idea of how it works, right? And if you guys remember, for those that already worked a bit with Starknet, you have, and we will see this in a minute, you have a storage struct that you have to define. So we have a struct, and this struct has to be named storage, right? And in this storage struct, you will put a variable A, let's say, which is, let's say, a U32, and you want to store this into the contract storage. So when you store this into the contract storage, what actually the compiler does is it takes the name of this, I will simplify it will hash it, and this will give us the exact location into the shelf where this variable will be stored. So if you want to add a new variable to the storage, you have to give it a name, you can put a type here, and then the type is being serialized and put into the storage. So let's say B, when we hash it, B might end up in this part of the storage, right? So here you can see the limitation where if you change the name of a storage variable, you actually point a different location in the storage. And if you remove one or add new ones, then you don't have that much issues because everyone is different location in the storage. But you clearly see rapidly, like if you have to change data into the storage, you have to take all of this into an account. Well, in Dojo, this works a bit differently. So let's move out now to how Dojo actually works in this specific case, right? So in Dojo, we have one central contract that we call the world. The world is a smart contract, regular Starknet smart contract, and as any smart contracts being deployed, the world has its own storage, okay? So remember the storage, we will see it at the shelves, right? So the world has its own storage. And when a user want actually to register data into the storage, they will not use this storage struct. Instead, what they will use is what we call model. Models are just simple struct into Cairo, and the models are actually contract that has been declared into the blockchain. But those models contains how the data you put in are serialized and can be stored. And what does it mean is when you want to write data into the world, you actually write models. You don't actually deal with the low-level storage. You just write model and you just read models, and this is how you interact data with the world. And remember, everything is stored in the world. Every time the world has a model being added, registered, written, we have events that are being emitted, right? And the events, the cool thing about events is like they are thing that allows you to have an external, like an off-chain component to actually index them. In the context of Starknet, we usually use the term indexing. And in the case of Dojo, we have one which is named Torii. And Torii is able to understand when a model is being registered, which kind of data it contains, and then it can see everything that changes. So every time you change a model, you write into it or you register new ones, Torii will actually be able to see that. And then Torii will just organize everything into an SQL database, right? And this SQL database can then be queried by the client application. And here you can have many ways of querying. You can directly make some SQL statement if you just want to access the raw database of Torii. But then you might want also have some subscriptions things. So then you can use gRPC, you can use GraphQL, and those interfaces allows you to have a subscription model. So you can have the data being pushed by Torii to the client instead of having a polling schema where the client is actually making queries every n seconds to actually get the data, right? And this is for the how the data is being read, but how we actually interact with data. So in Starknet, you agree, and in blockchain in general, when you want to change the state, what are you doing? You're actually sending a transaction. And when you send a transaction, you send a transaction to a deploy contract. And this transaction, you actually make call some entry points. What we call entry points are the public methods available in the contract. And those methods will actually change the state of the blockchain. You can change storage and you can call other contract and stuff. So how it works into Dojo is usually you don't call the world directly. What you are doing is you are deploying contracts. So in the case of Dojo, a contract is like a regular Starknet contract with some slight changes that we will see. But the idea is it will be the same flow. The user will send a transaction to this contract. This contract will actually interact with the world to read and write models. Okay? So this is the whole flow of Dojo. When you want to interact with the world, you call a contract. The contracts read and write data from the world, and those data are called models. Everything that happens into the world is being registered emitted into events, and Torii will index them. And since the models are on-chain contracts, you don't need to configure Torii to know your types. Everything is defined on-chain, okay? So this is the mental model of Dojo and how it's different from a regular contract, where in regular contracts, what you will want to do usually is you have your smart contract, you send transactions to it, and then you actually change the storage of your contract, right? It's more a direct model. So if you have events being emitted, then you need an indexer specific for the events of this contract. But if you have another contract, then you will have to repeat this process, right? In the case of Dojo, everything is actually centralized into the world, and the events are being formatted in a very specific way for every contract, and then Torii can actually index them correctly. I'm a bit sorry for the noise in the street. I hope it's fine, Robert. Or it's very loud.
No, it's perfect. It's perfect.
It's fine? Okay. So this is the metal model. Do we have some questions, Robert, or I can just move on?
Not so far, but let's move
Okay,
on, and now
that sounds
I'll
good.
let you know.
Sounds good. Thank you very much, Robert. So now let's go into the code. So the idea of today, I will try to copy paste some code just because I want to show you the whole thing in 1 hour. But what we will do is first, we will build some smart contract. Then we will see how we actually can test them very quickly. And then we will move into the client side where I want to show you a very simple application in JavaScript, but it can be with any SDK. I might just show you guys something I forgot to mention, and that might be useful for the future, is how we actually interact with Torii with the Dojo ecosystem. So in the Dojo, how it works is, as we mentioned, so we have Torii. Torii is being the indexer, which is responsible to get the events from the world and store this into an SQL database. So we have a Torii server, right? So a Torii server is just something we can start, is a Torii binary that is very quick to install. And then we have Torii starting to index the world. But then how we actually connect this into our application. So what we have, and we once again, I will say we will rename it, but we never did it yet. So we have a layer that is called dojo.c, but this will be renamed very shortly with something like binding or something similar. The idea is we have one code base for the Torii client that is being written in Rust that can be compiled into C, C++, or WASM, right? Or it can be used directly. And the idea of this is any SDK is actually using this at the root, right? So if we want to write code using dojo.js, then we just have to use the Watson build of Dojo.c. We have a contributor that did Unreal Engine SDK. It's based on Dojo.c. And we have also Unity SDK, which is also based on this one, right? So the idea is when we talk about Torii, we have a server, and then we have a client SDK. And in this case, I will just show you the rawest manner to actually use Dojo.c, but then you can use it in any SDK. It will be very similar. The SDK are just adding some interesting stuff like optimistic rendering, for instance, optimistic execution. So when a transaction is being sent, the front end changes its state even before the transaction is being accepted. And once the transaction is accepted, the state is validated. And if the transaction is reverted, then the state is also reverted, right? So this is a kind of things you can find into an SDK. But today I will just show you the Torii client in its raw form, just to give you the idea of how it works and what you can do with it, okay? So let's just dive into a smart contract. So in Starknet, as you guys may know, and I hope, the idea is it's a bit similar to Rust. So here in this case, we have a contracts folder. We have a lib.kero that represent all our modules. And here we will have two kind of things. Do you remember the models or the data we want to define? And the actions will be, in this case, just a smart contract that we will use to actually work with the world. So the idea is in Kero, every file you write is a module. Everything is by default private. Okay, so let's make a simple game where we will have a simple directional game. So this is a span and move example we always have. So you can spawn into the world, which gives you a position into the world with X and Y coordinates, and then you can move up, down, left, right. And this, when you move, you send a transaction, and then we should see this being reflected into the client, right? So let's start with a simple. I will just copy paste just to make sure we have time to see everything, guys. Okay. So let's start with a simple enumeration. So in Kero, when you have enumerations up here, when you have enumerations in Kero, they are serialized using the index of the variant, right? So in this case, left must be 0 when we serialize, and then 1, 2, 3, 3, and so forth. In the case of Dojo, we have some specific attributes you want to derive. So a derive is just a macro which writes code for you. So in this case, direction, when we derive Serde, copy, drop, we actually want to have the compiler generate code for us that we don't want to write manually. Introspect in the trait is a trait into Dojo to say, I want this type to be able to be stored into the world. That's it. And the type definition will be stored on chain, right? So we will have this direction, and then let's just make two models, okay? We will have two models, and the two models we will use is one to record the position of the player into the world. So we will have a X and Y. I will make it a bit bigger, maybe just to make sure it's okay for you guys. So we have X and Y, and then we have moves, which will just keep for each player how many moves it's remaining. Something you have to note here, we have the Dojo model attribute. So this is, once again, a macro that generates code for us. And the other one is the key here. And maybe you guys know already about the keys for the events. The concept of the keys into Dojo is to say, when you want to store a position model, how do I identify this data into the work database? And the keys are a bit like SQL indexes at some point, or IDs, better said. And the idea is the keys are never stored. It's something you have to provide to actually identify the data you want to read, right? And we will see in a minute how this will work. But here, the thing you have to keep in mind is we define some key fields, which are like IDs, and we define some data fields, which in this case are X and Y, and in this case are remaining. Key fields never stored, data fields stored into the database, right? So you have to know the keys to actually query the data. And something we will do very quickly is, as you guys might know into Kero, we can do a bit like Rust, which means we can add functionalities to some types. In this case, we have a very specific syntax here. So how this means? It means we will actually create a trait, which generate trait will do. If I don't use generate trait, I should have done this trait, position trait, and I have to define all the functions that I want this trait to define. Using generate trait is just a shorthand that just helps me going faster because I just don't want to reuse this that often. And in this case, we want to apply a direction when we take a model, right? So when we apply a direction, what we want to do is when we want to go left, we actually subtract 1 to x. And here we are using saturated sub because if we already at the position 0 in a grid where we don't have negative indexes, then we just want it to be 0. This is why we use saturated add and saturated sub, just to make sure we don't overflow the type we are using. In this case, it's U32, so we will not go higher than max U32 or lower than 0. As in Rust, when you are in Kero, things are not in the scope directly. So let me just go into contract, running Sozo build. I will show you maybe how to install this very quickly. So how you want to install Dojo, you have, I will put it here very quickly. I think, Robert, you sent the leaks, right? But maybe it wasn't, I don't
Let
remember.
me share them again.
Okay. Oh, maybe I should have shoved them into the conversation. Thank you. But the idea is with Dojo, we have a Dojo app script that you can easily install, and this will install the different tools for you. I don't have. Yeah, you already did it. Thank you very much, Robert. Yeah, perfect. So here, for instance, we have a bunch of errors. One of the best advice I can give you about compiler errors is always get to the top because you might have errors that are just disappearing once you solve the first one. So here we have few errors. Contract address not found, saturated sub not found on type U32. In Kero, like in Rust, every time you want to actually use types or traits, by default, everything is private. So if we want to use it, we have to use them. And remember, every file is a Kero module, but inside a module, I can have another module. But everything is private by default. So when I'm here, I cannot see contract address and I cannot see those things. I need to import them explicitly, right? So this is why here in this situation, we needed contract address, which is used at different location. And we needed the trait that is coming from the core lib, where we can actually have those functions being defined. And now if we build, we should have something a bit better and compiling, right? For now, compiling times are a bit high in Kero, but there is a huge efforts currently going on the compiler to have this very quicker. So yeah, for now you have to be a bit patient depending the dependency you use. So here we have defined models, right? So we have data and then we will use the data. So let's go into actions.kero, and in actions.kero we'll actually try to use those data. So how we will use those data? Let's go directly to how we will do it, right? So the first thing is to remember we want to create a module for our contract. So we will have a module that will contain our contract. But first thing we want to do is in Starknet, you need to define what is the functions, the entry points, which you remember entry points are public functions that you can call from your contract. How do we define them? Well, we define them using a trait, and this trait must use Starknet interface. So in this trait, we have a generic parameter here, and we are saying, I want to define two functions in my contract, I mean, in this interface, and this interface will have a ref self, which means I mean to modify the contract state, and then we might have another attribute here. So here, same thing as Rust for those who know Rust, we can use crate to refer to our package to avoid having to make like names that we might change in the future. So now we have this, where the only difference with regular Starknet contract is here we should have used Starknet contract. In the case of Dojo, we will use a Dojo contract. Why? Because the Dojo plugin compiler plugin will actually inject code for you that which allow different things out of the box without you having to implement them, right? And then in the case of Dojo, do you remember we have this world contract that we actually need to know? So the first thing that we will implement here is we will reuse this generate trait syntax, which is I want to define a trait, but I don't want to define it explicitly, so please generate it on the go. And in this trait, we actually want to get the world itself. The world is like a contract, but in the future of Dojo, it might not be a contract. So this is why there is this interface. And this interface says, please let me get my world, which I am associated to, and I want to use a namespace. Namespace, I will be very quick on that. The idea is, do you know in SQL database, you might have schemas. So I might have schema A, and then I might have table users. But then I might have schema B with also table users, right? So this allows you to have different tables with the same names in different schemas. Here is exactly the same. You can use namespace to actually reuse models, but in different storage locations. So it's like a logical separation of the data. But I will not take too much time there because in most simple programs, we only have one namespace. I mean, Dojo games, we only have one namespace and we don't need to care much about the other one for now. So let's get this to get the world. So the world default will actually get the world for me with the default namespace, right? In this case. And now let's just write some functions. So once again, I apologize the copy paste, but for the time we have, it will be a bit short to do the full things. In 2 hours it could be, but in 1 hour it will be a bit short. So what are we doing here? So same thing. We are using use statement to actually import things from different modules. Then we have some constant defines, and here we go into our two functions. So we have to implement two functions, which is spawn and move. So in spawn, what are we doing here? So first thing first, we are getting the world, right? So this gives us a reference to the world. Then we get the player. Let's say the player is just a user that is actually calling the contract, right? And then here we are just using the models. So the models are just data. And here the thing you can note is we use the same player as the key, right? You remember the key was the player address here. And then what are we doing? We are actually writing the models. So here, as you can see, if you remember the mental model I gave you at the beginning, when you want actually a contract to write data, you just do write model. And if you want to read data, you just do read model. And this reads and writes data into the world storage without you having to use this storage struct that you might have seen into a default Starknet contract. So what are we doing here? When we spawn, we actually initialize the data with a maximum remaining move and the init coordinate of 10. And when we move, depending on the direction, do you remember we had this apply direction function, which is just saying, depending on the direction we will apply and we modify the coordinates. This is what we do here. And as you can see here in very few lines, we actually are modifying the player location by interacting with the world. All right. So this is just checking. Okay. So this is a very simple example, but this is everything you have to actually know about how you interact with the world contract into a Dojo contract, right? So let's just try to compile this just to make sure I didn't forget anything, and then we should be go. About the testing, I will not spend that much time here, but the idea of the testing is Dojo will soon support Starknet Foundry. So for now, it's still using the default Kero runner. And when you use testing, I will send you links, guys, for those who will go with Dojo. You actually set up your world. So you have to set up the world. Maybe I can show you very briefly. But I think it might be, yeah. So the idea is you set up your world and you actually define the resources you want to register into your world. So if I give you an example here, there is some utilities function into Dojo Kero test. And here we actually define how the world will look like. So here you can recognize the namespace we're using. You can recognize the different models we are using and the contract actions. So once we define everything that is inside a namespace, then we can actually interact and use it. But I will send you guys anyway links to this repo with all the code and things. The idea here in 1 hour is giving you the general panorama is what you can do. So this is a contract that we have that is compiled. Do you remember when we compile, we actually have different files that are being generated here. And here you can see we have different contracts. We have the actions contract, but as I remember, I told before, for every model, we also have a contract being generated by Dojo, right? And this one is the famous word contract. So if I go into the scarp.toml file, we still have this build external contract, which is we always want Scarp to build the world because we want to deploy the world for our game. So each game has its own world, but maybe you want to expand other games' world. So you can also compose and add things on an existing world. But this is for other applications and I mean extensibility and stuff. So this is a basic of smart contract side. Okay. So now let's go into the the client side. So if we go into the client side, let me just show you guys. So the idea of the client side is we will just do a very simple client. And this client, the idea is we will have spot and move. We can connect, and I will show you how to actually integrate controller. And then we can move from the UI, and we will see that without polling, we will have Torii pushing the updates for us. And this is how you have a reactive client that is actually isn't polling, but reacting to the changes into the blockchain, right? So something I need to show you quick is since we have our contracts, let's just try to actually deploy those contracts. So in Dojo, we have, is it okay for the font, Robert? I will try to make it a bit bigger. I think it's better now.
Yeah,
Yes.
yeah, that looks good.
Okay. So in Dojo, we have different tools. We have Katana, so Katana is a sequencer that you can use for testing, but it's also designed to be run in production when your game will not end up into a public network, but it can be used in a hosted sequencer. But most of the time, you can use Katana for testing, integration testing, and then you can move to Sepolia on or mainnet. So we have Katana, which is a sequencer. We have Torii, which is the indexer. And we have Sozo, which is a tool for streamlined contract management. So as you have seen to what we have done into the contracts, we have Sozo build, which is to build the things. This is using Scarb under the hood. And then when you want to work with Starknet, you need to declare and you need to deploy, and then you need to initialize those contracts. With Dojo, we can do that in only one command. So I will start Katana with a simple configuration. The configuration is just to start Katana into dev mode. And then I will just hit Sozo migrate. But before Sozo migrate, I will use Sozo inspect. Sozo inspect gives me everything that I have into my world. I have the world contract, the namespace I have by default, and then I have the contract. So here you can see the contract actions and you can see the models. When I hit Sozo migrate, what Sozo will do is it will check all my local contracts, all the state of those contracts into the blockchain I am targeting. In this case, it's Katana, and it will actually make a diff. And this diff will give to Sozo which contract has to be deployed, which contract has to be declared, and which one um, has to be initialized. So here, as you can see, Sozo is actually doing all this stuff for me, and then the world is being deployed, right? And if I do Sozo inspect again, this time it will give me the status of each one of the contract, which is actually synced to the blockchain. And every time you change something, you just have to rebuild and hit Sozo migrate again. And if you only change actions, Sozo will actually only migrate actions and not the other ones, right? So now we have migrated. It means on Katana, here you can see we have some transaction that has come in. We have the contracts declared and deployed now into Katana. How do we index those contracts? So we will use Torii. And how Torii actually, oh, it's not the same font. Let me just, yes, better. Then how Torii is indexing. Torii, the only thing it has to know is the contract, the world address. This world address is the one we have used here, and just which is here, sorry. And once we give this to Torii, if you remember, everything that happens into the world. So every time we actually do this right model, an event is being emitted and Torii will be able to index this, right? So you don't have anything specific to do. You just want to start Torii, you just give to Torii the configuration, and with this configuration, Torii is already indexing. Here, as you can see, we have some registered model already detected, right? And maybe I can show you quickly how to send a transaction with Sozo. And like this, we will see Torii actually reacting to that. So if I get back here and I will go to Sozo, with Sozo, we can do execute, which is the same word for invoke. And in Sozo execute, the cool thing about Dojo is we know everything about contracts names. We don't need to give an address. So I will just give the namespace dash the name of the contract. I want it to spawn, and then I just hit enter. And this sends transactions. And here, as you can see, in the Torii side, we actually have this record being set. So Torii has detected the moves model and the position model has been written. And Torii, as I mentioned earlier, has a database. So if I go to localhost 8080 SQL, and here I want to see the DI moves model, then Torii already registered the moves, right? And the moves, if you remember, we have this remaining, which is initialized with 100. But I can also check the position. And here I have my X and Y, which are 10. So here, without actually doing anything more than starting the indexer and setting a transaction, as you can see, the data are flowing through my local development things. I send a transaction, the state is being updated, and Torii get this update. All right. So this is the thing that I wanted to show about this part. But now let's just get to the client. So for the client, guys, I think I will just go into the main branch and show you because we have only 20 minutes left. No questions, Robert? I think not.
So far, so good.
All right. So I will just show you the skeleton first, and then I will be adding the code. So the idea here is, as I mentioned, we are using the Torii client in its raw form. Here, the raw form of the Torii client is just a WASM package that has been compiled from Dojo.c, and I'm just using this directly here. We could use Dojo.js directly. We can use Torii client. I think it's also a package. But the idea here is just to show you like how it is under the hood, and then you just have to use the higher abstraction things, right? So the idea here is this interface, what we want to do is we want to connect controller when we hit this button, and then we want to be able to send transaction and see this happening. So let me just get back into the main branch. Like this, we have the code. So some of things that I want to show you here. So controller is cartridge embedded wallet. The idea of controller is you can use session tokens, session keys to actually have into your computer a session being signed, right? And then you can send transaction and you don't have to prompt the user every time to accept the transaction. And when you actually logged in and then you sign, you can use passkeys or you can use different things to actually ease the onboarding on of your users. The only thing you have to define when you work with controller is policies. The policies are which contracts I want to allow the session to interact with. So you can have a very fine-tuning control here, what you want actually to expose into the session. Everything that is exposed into the session will be able to be signed and send a transaction, and then the transaction will actually be first checked to see if it's inside the policy before execution. So here we have a very simple way to initialize controller with the options, and this is an example of a policy. We have which contract address we actually want to whitelist, what is the name and the description of the contract, and then we have the list of the methods. And in the list of the methods, in this case, the spawn and move must match the name that we have here, spawn and move, right? So this is how we set up controller. Then in the game itself, what we will do is every time we actually click a button, we want to move. And how we will move, we will send a transaction to the blockchain. How do we send a transaction? When you initialize an account into, you have Starknet kits or different connectors in controlling the same thing, you just have this account and then you call the execute method on it. And this execute method, in the case of controller, will actually use the session that we have initialized, right? So in the case of spawn, we just want to call the spawn entry point without data. And in the case of move, we want to call the move entry point. And you remember in Caro, you need to actually to serialize the data. So in the case of a direction, as I mentioned earlier, we have to use the index, right? So 0, 1, 2, 3, 4. So this is what we have here, 0, 1, 2, 3, 4, right? And then we just executed send this transaction. And our index, what will actually happen is we will actually connect to Torii to ask Torii two things. You can fetch data to Torii, so you can say, hey, Torii, give me all the entities, all the models I have into the world right now, and it will get it to you. So here, this is an example of doing that. We have a query. In the query, we have pagination system. We can define clauses. Clauses is, I want to get only the models that have a key that is equal to 1, right? The first key equal to 1. Or I want all the models for this player address, right? So this is what you can define into clauses and more. So the idea of the clauses is to be very flexible, to just give you a way to actually query the data as you want to query them. And here we use get entities, and with this query, we actually get the data and we can display them. So the functions here, update from entity data, is when we fetch data from Torii, we can have all the things that are into the storage, and then we can represent them into the application. But the most exciting part about Torii is, I mean, fetching is great, but you also have subscriptions. So usually you will have the fetching happening first, you set up your game, and then you have subscriptions giving you all the updates. How the subscriptions work? Same thing. You have a clause. The clause can be on different things. So in this case, we just put indefined, which means gives me everything. But let's say we are in the case where the user is connected. So here we might want to do something like this with contract address, right? And if we do that, Torii will actually notify us every time a model with the first key equal to this contract address has changed, right? So if we go back into the models, in our case, we have position and moves where the first key is a player. So in this case, we will have the two models. But maybe we want to filter the model. Oh, I only want to get the data from positions. So I can filter also by models, right? Or if we have, let's say we have another model later that is being defined, and this model will be other model, and here we have not a player, but an object ID, for instance, right? If we have something like this, then the object ID not being the player address, this model will never be returned, right? So this is how you can actually design your models, thinking of the keys, because when you want to query, you will need to give those keys, and this is how you express the query system into Torii. For those who are familiar with game development, there is this ECS pattern that is being used in different game engines and software in general. And this is very inspired from there, right? So the models are the components, which are the data. The systems are actually the functions, the entry point of the contracts, right? And this is, and the entities are just the keys. So in this case, the player is an entity. If I have the player into a game, so let's say I have, let's say for instance, a game here, I might have a player address, but then I might have a game ID, right? So here, player is an entity, but player combined with game ID is another entity. So this is how you have to think about your models, and then you can query them very easily from Torii. So in this case here, we have, let's put together in define, the variable length is just to know if I put variable length, it means I don't care about the number of keys into a model. But if I put fixed length, it means I want to match only the models that have one key. If I want two keys, I can do something like this, or I can do two. In this case, it means I want to match everything. I don't care about the first key. I want the second key to be equal to 2, and I want only exactly 2 keys, right? And if I go back to variable length, it means I don't care if the models has more keys, right? So this is something that once you get it, this is how you actually structure your models and how you query them. And here we just keep the subscription open and then we go. So let's go back into the demonstration there. So let's go here. We're still running, I guess, yes. Okay, so let's first connect to controller. Controller is using like an iframe to actually show you how you can connect and get the session. So if you run something that doesn't exist, you can sign up, or if you run someone that exists, you can actually log in. When you're logged in, you can use passkeys, social login, and different things. In this case, I will upgrade my controller because I redeploy in Katana and I just need the controller to be upgraded to the latest version. And here, this is a session. So do you remember into the code, we actually had the controller file where we defined the names of the contract and the different actions? This is exactly what we have here. We have the contract, the address, and the different methods that I actually want to allow the sessions to execute for me. And once we are connected, here, maybe you will be able to see. Up. But do you remember into the code, we have a fetch from Torii. And this fetch, as you can see here, we have fetch data. Do you recognize here the two models we actually have defined and the data we have set? So as we have used Sozo to spawn, we already have the model here. So as you can see, we have the moves, positions, and Tories know everything about the types. So the clients with the SDK where there is a type layer, everything is typed directly. So your application doesn't have to actually deal with typing things. Everything is being generated, and Sozo also have some bindings generators. So here we can spawn from the console here. And as you can see here, those two things are actually being pushed by Torii. So let me show you again when I'm spawning. So when I'm spawning, I'm sending a transaction. Then when we spawn, you remember we have this spawn and move. We have the moves and position models being written. So we have two things being changed. So if I clear my console and I spawn again, you can see here we have two subscription events. So in this case, we are into the subscription events, which is here, right? So when we have this coming in, we want to update the front end here. And now I will click down. So when I click down, same thing. I send a transaction. When I click down, I change the X or Y depending on where I'm going. In the case of down is X, is Y. And here, same thing. Everything that has changed is being notified to the client. And here, there is no optimistic rendering. So it means the time I click and the time the UI changes is the full loop. I send a transaction, the blockchain is being updated, Torii is getting the events, updating his database, and pushing it to the client, right? So this is a full loop that happens. And here, as you can see, with very few line of codes, because here we have the Torii query just to initialize the state, and then we have the subscription, and the update from entity data is just a function that is actually iterating on all the entities that has been changed. And if it's position, then I update X and Y into the UI. If it's moves, I update remaining move. That's it. So the code is quite small, but Dojo gives you this automation of when something changes into the blockchain, you are notified immediately when you use the subscription model. And you are notified with types and all the namings you have. So this is something that I wanted to show. So maybe, sorry, I went a bit fast into the code, but the idea was to give you this overview of building from scratch a small smart contracts using Dojo with this world concept. So as you can see here into the actions, it's still a very simple code, right? Where we write into models, and then we have this automatic indexing by Torii. So everything changes, Torii gets this and send it back to your client. And showing you controller, as you can see here, I'm not actually validating and signing every transactions. I just sign the sessions first, and then the session will actually sign the transactions for me, right? So all movement in the game are recording on chain. Yes, exactly. So in this kind of in this example, everything that I change, which is X and Y position remaining, everything is changing into the state. And you're right. Transactions right now are gas fees are very cheap on Starknet. So we have some games in production and studios building with Dojo where everything you do is actually on chain, but we have some different things we are working on to actually like deport this execution out of Starknet and just sending a proof that everything has been executed correctly using exactly the same code. So this is how you can actually reduce even further transaction fees. But for now, transaction fees are pretty cheap on Starknet. And the transaction approve automatically. In this case, if I refresh my page, when I connect controller, I am actually here signing in. And once I sign in, here I am signing a session. When I sign this session, then the session token that I can show you that should be somewhere like uh, into the storage. Yes, take. So here in X, here we have the controller, and then we also have the active sessions, right? We are working also toward like you can list your session and revoke sessions and define how many times you want the session to be active. But the cool thing is once you have a session, you can do everything that is allowed into the policies you have signed in. And in this case, I can spawn and then I can move because I define this. Um, I hope it answers the question. Yes, on chain. So yeah, everything is on chain here, And here, Dojo is actually giving you this reactivity into your client. In this case, the client is JavaScript. But as I mentioned, we have people building with Unreal Engine, with Unity, with Godot. Something is coming, and Bevy also. So the idea is just plug in Dojo there. Dojo gives this blockchain data, and then the engine is just like connecting and allowing you to send transaction and doing this engine game. So yeah. What the workaround from optimistic rendering? I'm thinking of an idle clicker type when everything type would be an action. So yeah, so how optimistic rendering works? Let me show you quickly to give you the intuition of it. Okay, so let's say this is our client application, which is the game interface, right? So when someone actually into the client pick a button to send a transaction, the transaction has to go to a network. Let's say it's Starknet, okay? Once Starknet receives the transactions, first the transaction needs to be validated. When the transaction is validated, it needs to be executed. And once it's executed, for now in Starknet, we're at what we call the pending block. So it means even if the block is not mined, you can check the soft validation of the transaction and the new state of Starknet even before the block is not mined. But soon we might not have this pending block again, but the idea is then the block needs to be mined, right? So when the block is mined, it's like, okay, it's on L2, and then we have it here. So the idea is once we have this change, then we need to get those changes and reflect them into the client. What Torii gives you is you don't have to read the chain. Usually, when you want to read something from the chain, you just make a call to a contract or you read the storage directly, which can be very cumbersome. The idea here is Torii gives you that. Optimistic rendering, it's like a small box that you can put here, optimistic rendering. And before the text is even sent to Starknet, the client will actually update its local state. And this local state will reflect the change. And then there is two scenarios. Once the transaction is done, if the transaction has been rejected, then the optimistic state must be reverted, right? So you might have, like your client might handle this differently, but this might make your client have things disappeared even if it was there or stuff like this. But as most of the time the transaction will actually go through, then you have your state being updated, and in the back you actually have the confirmation that the transaction went through and your state is being validated locally. So this is what optimistic rendering does. In Dojo.js, there is optimistic rendering. In Dojo Unity, I think there is something related, or I don't remember exactly, but the idea is depending on the SDK, you might have your layer of optimistic memory. What structure you recommend if you want to connect an AI avatar live conversational to improve? Okay, so when you speak about connecting AI, you have seen that using sessions is very useful because using sessions means you as a user, you can sign a session, and then you might give this session to an AI agent to actually interact with your contract, right? And you can define the scope of what the agent will be able to do. The only thing you have to consider here is everything is transactions. So if your agent is actually doing thousands of transactions per second because you want to make a bunch of things, then you might have to consider this at a cost. But yeah, as an APC, that's a very good example. So if you want to make an NPC, you might have a session signed for very specific things like the NPC can do. Then you give this to AI, and AI can decide to send transactions based on something that has been interacted with another prompt. Yeah, exactly. So this is a very good example of how you can use sessions and then not have to sign like a user human signing for every transaction. Yes, that's very good. But just keep in mind that you will still need to pay those transactions, right? But this is the idea, yeah. Okay, I think I covered everything I wanted, even if it was a bit fast, but the idea was to give the full overview with some Starknet context, so hopefully it was useful for you guys. But yeah, I think it's all for me. Very happy to answer any question on the Telegram or Discord. And if you are building with Dojo, please don't hesitate to join Dojo Discord or Cartridge Discord and let us know. Like this, we can give you more support if you need to outside of office hours. Thank you, Robert.
Thank you very much, Glihm. Maybe I have a question for you before we wrap up the
Hmm.
session. In the meanwhile, maybe the participants can also ask on the QA if they have. So my question is more generic, I would say. So the question is like, what type of applications would you like to see built during these hackathon? Are there any specific genres or mechanics you would think it would work well with the Dojo engine and Starknet?
Very good question. Dojo can be used for any kind of application. You can do a DeFi application, you can do a small user app, you can do a game. The idea is it's just a different model. So games for sure are very interesting to see because games are very demanding and we love to see what people are building. And I mean, cartridge is built around game culture, right? So we love to see games. So even if you have a small idea in mind, like the clicker idea that I've seen into the chat, say, that's great. Just experiment with the stack, integrate controller, these session keys, and just propose a very smooth experience to your user. This is what we are also looking for. So Dojo gives you those two things, this easy way to build contracts, automatic indexing, and then you can have control on top. So I would say it's very open. It's not because it's not a game that it will not be considered. Definitely not. So you can also feel free to build application. But if you have a fun idea of games, I mean, feel free to do it. Even if the game is simple. As we always said into hackathon is if you can make a project from zero to something that works on public network, that's a huge accomplishment, even if the logic as first is perhaps simple, because at least you have the full flow. For sure, then when we have a bunch of submissions, you want to see who did more, right? But the idea is, I would really encourage you to go this because it's very satisfying to reach a point where you deployed something on public network that actually works and can drive users.
Fantastic. Thank you for the answer. And I think there's another one in the chat from Chris. What best practices have you found for hiding signature spam?
Signature spam. Well, I don't know exactly what you're referring to. In blockchain, as everything is permissionless, the first mechanics you have to avoid spam is obviously the fees, right? Because you still need to pay something, so you cannot spam things. But can you be perhaps more specific? Or I don't know if people can speak, but yeah, maybe more specific.
Yes, I will wait for a bit more clarity on it.
Mm-hmm.
Maybe they referred to like privacy signatures or something like that. But anyway, I think if you want, you can also we can also follow up on the Telegram chat where you can
For
ask more
sure. Yeah.
specific questions. But again, thank you so much, Glim, for being here. This was an amazing deep dive into the fundamentals of Dojo. I'm honestly quite excited about the like possibilities of the Dojo engine, and I'm also amazed of what like you and your team at Cartridge has been building so far. There's so many innovative things coming out there, so super exciting. Just to give a quick recap of today's, or in general of the hackathon, we had the kickoff session where we presented the $33,000 in start prizes. We learned that we had three workshops so far. We learned about the Starknet fundamentals, rapid developments with Scaffold Stark, and learned about the fundamentals of Dojo. For tomorrow, we have planned three more sessions where we'll start at 2 p.m. UTC. We'll have Bringing Yield to Bitcoin with Starknet. We'll have at 3 p.m. UTC GP SDK, ship on mainnet under 1 week. And finally, at 4 p.m. UTC, Driving Growth through product. All of these workshops are handcrafted for you to help you through this hackathon and give you the edge you need to win this. Before you go, make sure to join the Telegram channel. We have everything there. Everybody's there. The mentors are there to support you, any technical questions you may have. And teams are forming there right now. So if you're missing a team member or you're searching for a project, make sure to check it out. And yeah, super excited for tomorrow's sessions as well. Thank you all for joining and wishing you a fantastic day ahead. Thank you so
Have a
much.
good one, guys. Thank you very much, Robert.